Hello, everyone. Now we're going to introduce the BFD technology experiment. And let's see the background of this experiment is a bank's branch and the secondary branch devices are connected over an ISP's private line with services interconnection enabled through the OSPF protocol. To ensure high reliability, customer plans to add bidirectional forwarding detection configuration. However, customer lacks experts in configuring BFD. So the service manager for this bank intends to use a simple technology to provide customers with a clear overview of BFD, including its usage scenario, working principles, relevant configuration, and status viewing commands. So by using this lab, we hope that you can understand the technical principle of BFD, master the configuration, and learn about BFD application scenarios. As you can see, the topology is shown here, and I built it by using the simulator. The topology is the same. And the requirement is that the interconnection address of R1 and R2 are 12.0.0.1/30 and 12.0.0.2/30, respectively. The loopback zero address of R1 and R2 are 1.1.1.1 and 2.2.2.2. OSPF protocol runs between R1 and R2, and the loopback interface and the interconnect interface are advised into OSPF process. When an exception occurs on the ISP's network, R1 and R2 can detect it, make OSPF neighbor state quickly switch from 4 to 9. To achieve that, let's see the configuration plan. Complete basic configuration, for example, the IP address of the interconnection address and the loopback interface, and complete OSPF basic configuration, complete interface BFD configuration and associated with BFD. Okay, so let's see. First is the basic configuration of the IP address on both R1 and R2. Okay, so on R1, we should enter the configuration view and firstly create a loopback interface. Interface loopback 0 and IP address 1.1.1.1/32. And for the interface G00, IP address 12.0.0.2/30. And for R2, actually is similar. Let's do it on R2. Okay, so until now, we have finished the basic configuration of the IP address on both two routers. And next is a configuration of OSPF on R1, let's say it. Router OSPF 1, router ID 1.1.1.1. Network. Okay, and then network 1.1.1.1. Wildcard is 0000, and it belongs to area 0. And next is our interconnection subnets. Here, since we only have two interfaces, so we just network the specific or the exact address of the interface. Okay, this is on R1 and then R2. Router OSPF 1 and router ID 2.2.2.2. Yes, and network 2.2.2.2, area 0. Okay, and until now we have finished the configuration of the OSPF, and as you can see here, they have already established the adjacency. Okay, next is the configuration of BFD interface G00 BFD interval 100 mean RX 100 multiplier 3. So this is the configuration of BFD about the intervals, about the multipliers. And next we should associate with OSPF, so IP OSPF BFD. Right. And here's a warning. BFD for OSPF neighbor should be enabled. Yeah. And we can use show this. You can think we have successfully finished the configuration of this interface. And let's go to R2. Okay, on this interface, first the BFD interval 100 mean RX 100 multiplier 3 and associated with OSPF, so IP OSPF BFD. Okay, and you show this, we can also see that we have successfully configured both the BFD and the association between OSPF and BFD. So at last, we can verify the results. We can use the command show IP OSPF neighbor to check the neighbor relationship. Okay, let's see it. On R1, show IP OSPF neighbor. You can see it has a neighbor and the state is 4, and the BFD state, pay attention here, BFD state is up. Means they have already established the OSPF adjacency, and the BFD session state is up right now. And we can use the command show BFD neighbor. We can check the BFD relationship. You can see it established a BFD with the local address is 12.0.0.1 and the neighbors is 12.0.0.2, and the state here is up right now. Okay, and then to verify the result, we can shut down the switch simulation line for the ISP network. Check the BFD status changes. So let's see how. For example, on S1. Maybe we interface G01. And then let's see what we should do. We shut down one of this interface. So shut down. You can see this interface is shut down and it changes state to up. So let's go back to the router. You can see firstly here it's an alarm. BFD session state is down. All right, BFD session to the neighbor 12.0.0.2 on interface G01 has gone down. Reason is the control detection time expired. Okay, so from here we can know once the interface is down, BFD session will down. And if we use the command to show IP OSPF neighbor, you will find that there is no neighbor, right? Because the BFD is down, so BFD will inform OSPF that okay, the neighbor is unreachable. And then we restore the network. Means for this interface, we can use no shutdown. It's up. And let's go back to the router. You can see show IP OSPF neighbor. You can see here, right? It's loading to 4. So we check it again. You can see it's recovered. And then to verify the function of OSPF, so here we delete the command IP OSPF BFD on the G00 on R1 and R2, and then check BFD status. BFD neighbor relationship is not established as showing here. So let's see it. In phase G00, no IP OSPF BFD. And for R2 is same. In the phase G00, no IP BFD, IP OSPF, sorry, OSPF BFD. Okay, and then if you use a command to check show BFD neighbor, you will find there is no BFD neighbor. Okay, so this is about the configuration of BFD, which is associated with OSPF. And by this experiment, it shows us that BFD must rely on the IGP to establish neighbor relationships. Once the IGP protocol fails, the configuration of BFD will also fail. BFD can quickly detect the remote link failure to ensure the time response. And about this experiment, the key point is that BFD can interoperate with static routes, RAID, BGP, in addition to OSPF. Okay, I think that's all for this lab.